Okay, let us study terminating decimal and non-terminating decimal. First of all, you should know what is terminating decimal. In terminating decimal, the decimal stops, it ends. It is a decimal with a finite number of digits. For example, if you take 1 by 2, if you convert this into decimal, that would be 0.5. If you let us say 1 by 4, that would be 0.25, right? So after the decimal place, there is only one digit, non-zero digit we are talking about. Here after the decimal, only two digits. Now what is non-terminating decimal? A decimal that has infinite digits after the decimal point is called a non-terminating decimal. For example, if I say 1 by 3, if you convert into decimal point, that would be 0.33333 up to infinite, right? Similar, we can say 2 by 3 also, 0.6666 up to infinite. So this is the difference between terminating and non-terminating digits. Now, how to say whether a fraction a upon b is terminating or non-terminating decimals? How to find that? See, a fraction a upon b, where a and b are the integers, is terminating if and only if the denominator, let us say a upon b, if the denominator is having the prime factor only 2 and 5, it means no other prime factor in the reduced form. What do you mean by that? Let us say I told you a is an integer and b is an integer which is having only 2 and 5 as a prime factor. For example, b can be either 2 or 5 or 2 into 5, right? It can be 2 square into 5, 2 square into 5 cube, or only 1, 1 into 5, anything. Means this should not have any other prime factor except 2 and 5. In that case, we can say this will be a terminating decimal. Terminating decimals. Now, what if this is having any other prime factor except 2 and 5? For example, let us say 6. Can you say this will be a non-terminating? No. If we have any other prime factor except 2 and 5, then we have to check what is the numerator. For example, if let us say 3 by 6. If denominator is having 2 and 3 as the prime factor, but numerator is also having 2, 3, so we can cancel this out. So after simplification, it is 1 by 2. After that, we have to again check, yes, this is having only 2 as a prime factor, so this will be a terminating decimal. So always remember, whenever we have a upon b factor like this fraction, right, where both are integers. Now, if b is having only 2 and 5 as a prime factor, right, 2 or 5, no other prime factor, then doesn't matter what is the value of this integer, it doesn't matter. Even if we do not know what is the value of this integer, no issue, this will be a terminating decimal only. But if let us say this is having some other prime factor, for example in the case 3, in that case we need to see what is the numerator, because maybe we can cancel a few factors. For example here, after we have cancelled, it is only 2 in the denominator. So the question says in the reduced form, simplified form. If in the simplified form only 2 and 5 is the prime factors, this will be a terminating decimal only. If after reduction, let us say 2 upon 14, right? Or let us say 2 upon any number you can take, 2 upon let us say 15. Okay. So if even after reduction, let us say if you reduce this 1 by 7, this is the only reduced form. So any after reduction also, if there is a any other prime factor except 2 or 5, this will be a non-terminating decimal. This we need to remember. Okay, now let's go to some of the questions. Try this one. You can pause the video to try this question. Now, if you see this question, they are saying if p and if is p upon q a terminating decimal. Now let us see. P is a prime number. Okay. So it is giving no information about the denominator, so this is not sufficient. Now q is a factor of 100. Now 100 I know is 2 square into 5 square. So if q is a factor of 100, it means q will never have any prime factor except 2 or 5. No other prime factor. That is clear to you, all of you, right? Q will never have any other prime factor except 2 or 5. Then what can you say about P upon Q? Can we say since P is only having the prime factor 2 or 5, it means this will be a terminating decimal? Can we say that? Terminating decimal? No, we cannot say. Why? Because even if Q is having 2 or 5, let us say Q is only 2, then also you cannot say P upon Q is terminating decimal. Why? Because what about if P itself is 1 by 3? Then again it would be 1 by 6 would be non-terminating, right? So since we do not know what is P may be non-terminating itself. That's why statement 2 alone is not sufficient to answer. And this is the trap one here. Because most of the student mark B, they say Q is having only 2 or 5 as a prime factor, no other prime factor. So this will be sufficient to say this will be a terminating decimal. That is wrong because we do not know anything about P. P can itself be a fraction or maybe itself be a root 2 or any other non-terminating decimal. That's why statement 2 alone is not sufficient to answer. But now if you combine both the statement 1 and 2, then you can say P is an integer. Prime number is a positive integer. So integer, and this is having only 2 or 5. So this will definitely be a terminating decimal. That's why C is the right answer to this question. Okay, I hope it's clear. Now let's do similar second question. See, here very similar. I have changed only the statement 1. So you can pause the video to try this. Now, if you solve it, same case here. From this you know Q is having only 2 or 5 as the prime factor, no other prime factor. But P is a rational number. It means, what can we say about a rational number? Again, it can be an integer, it can be a fraction, 1 by 2, 1 by 4. It can be 1 by 3, 1 by 7 also. So now, even after combining, you cannot say whether it is a terminating or not, because if P is an integer, let us say, then it is terminating. Because integer divided by 2 or 5 will always be a terminating. If P is a rational number, let us say fraction, in which the denominator is like this, 2, 4. It is a rational number of terminating type. Then again the answer will be terminating only if P is terminating decimal. But if P is non-terminating decimal like 1 by 3, 1 by 7, in that case the answer would be non-terminating. So even after combining we cannot answer this. So E is the right answer for this question. I hope it's clear. Let's go to the next one. Now, is P upon Q a terminating decimal? They are saying P and Q are the positive numbers. Now, if P and Q, now they have given P and Q are the positive numbers. In this also we can do the same thing. From the statement 2 we can say Q is a factor of 100. So Q will be having only 2 or 5 as the prime factors, no other prime factor in this. But if you, from this, can you say what is the value of P? No. They are giving P and Q are the positive numbers, right? This is very important. They are saying positive numbers, not positive integers. That's why even if we know P and Q are the positive number, that is insufficient. We do not know what is the value of P. Again, the value of P can be an integer 2 or it can be 1 by 3. Both are positive. That's why P is 2 and this is 5. It would be terminating decimal. If P is 1 by 3 and this is 5, this will be non-terminating decimal. So statement 2 alone is not sufficient. But yes, if you combine, then you come to know P is a prime number, so P has to be positive integers. Now, if integers and this has to be 2 or 5 or any other factor of 2 or 5, right? We can say 2 or 5 square into 2, anything. So no other prime factor except 2 or 5, so this will be a terminating decimal. Now, the same question, if let us say they have asked, this is integers. If this is an integer, then you can say, what can you say? Then from the statement 2 alone, we can say this is sufficient because as we know, P is an integer, positive integer, that is sufficient to say this will be terminating. If the question had been integer, then the answer would have been B. This way we should be very careful about numbers or integer. If they have given integers, then we have to take integer. But whenever they say number, we should be taking both integer as well as non-integer. Okay, I hope it's clear.